Hello, everybody. This is Dr. Gardner at the University of Montana. And today we're going to be introducing Flopy, which is a Python library written by a variety of people, including the United States Geological Survey and others, that it essentially has a whole bunch of utilities for interfacing with MODFLOW. All right, so it creates the input files needed to run MODFLOW, and then has utilities for reading MODFLOW output and making plots. So Flopy, as a general overview, Flopy is a Python library which is a scriptable user interface to MODFLOW. And I am coining this term scriptable user interface, or SUI. All right, so this is basically just a set of Python functions and utilities, and the idea is that Flopy provides methods and utilities to write all the input files we need to run MODFLOW, there is some utility to run a MODFLOW simulation from within Python. Now, I'd like to just make a note here that you don't have to run MODFLOW using Flopy. It's just that you can. So you can write all the input files, and then you can run MODFLOW externally, depending on your system. If you're a Windows user, you can double click on that executable and it will run, as long as it's in the same directory with all the input files. Or if you're on a Unix machine, you can run it from the command prompt. But you don't have to run it from Python, you just can. So in your script, you can actually call and run the simulation using these Flopy tools. All right, and then there's also utilities to read MODFLOW output files, make plots, make calculations, whatever they might be. All right, so, you know, in the modeling world, this would be pre-processing. And this would be post-processing. And this would be simulation. All right, so Flopy gives us the ability to do all three phases of the modeling: the pre-processing, the simulation, and the post-processing. Again, I want to emphasize that Flopy is simply a wrapper or a Python library, which is an interface to MODFLOW. The actual MODFLOW is a standalone executable. Okay, so again, you know, Flopy is a very awesome set of software and has tons of power, and we cannot. First of all, I don't know everything about it, and secondly, I can't cover all of it. But just some basics that have helped me in understanding and using Flopy. So, some basics. So the art of, or the process of creating a model in Flopy is basically creating a series of Python objects. So Flopy breaks a model up into sometimes nested series of Python objects. All right. And if you don't know, which many of you won't know, what a Python object is, this is worth a pause on this video and doing a bit of a Google deep dive on what a Python object is. But it's essentially a programming unit that's both sort of a data type, hosts all kinds of parameters and data, but also includes things like functions, or in it's called a method if it belongs to an object. So it's a way of it's a container which holds data or variables. All right. For example, the hydraulic conductivity of a layer would be a data or a variable that's host within this Python object, or has methods, which are functions associated with that object. All right, so writing an input file, for example, could be a function that's associated with it with an object. Yeah, so as I said, you might want to just pause this here and just do a bit of a deep dive on what an object is. There's lots and lots going on with objects, and it's an abstract idea, but it's essentially trying to provide these containers which hold both data and methods. You can kind of, you know, just nuts and bolts, sort of really basic and not maybe computer science correct, but when you're looking at Python code, you can tell when someone's using an object often because we access an object's attributes with the period. So so we access an object's attributes, for example, a variable. With this, it'll be something like the object dot variable. All right, and so this dot tells me I'm accessing some attribute of an object. All right, and so an example, not that you need to know everything with this example, but an example of this kind of syntax is the top level object in a Flopy simulation is the MODFLOW model object. And this object, if we were to call it, we might say something like this, MF, and this is going to return a MODFLOW model object with the name of MF. All right, and so this is under the Flopy library, under the MODFLOW set of sections, and here is the object MODFLOW. All right, that is the object. And then this would have parentheses. And I'm going to continue the line down here. Toth. And if I looked at the documentation for this object, it would say that the first argument when I initiate an object is the model name, all right? And then the next one would be exe-name, the executable name, which on my computer would be ./mf 2005, which basically points to a file on my machine, all right, in the directory, that my current directory that's named MF 2005. All right, so when I call this, I initiate this object. It's this MODFLOW object. The object's name is MF, and it has a variety of attributes. So the simulation name, the model name will be Toth. And so I could access the model name by this mf.name, and that would return Toth. All right, mf.exe_name, that would return ./mf 2005. All right, so this is my object, and these are the attributes. All right, and this is how I sort of access those attributes. Now, an object can have lots and lots of attributes. One of the attributes could be a function, right, or a run. So to run this, I might say, I don't know what the actual syntax is, but there could be a function that was like run model. and we would write mf.run model. And usually we denote a method by having parentheses. And if it doesn't take an argument, there's just an open and a closed parentheses. All right, so this is the object, right? And these are the attributes. All right, and the object is just a convenient container for all these attributes. Okay, so in Flopy, all packages have their own object. So remember that we build a MODFLOW model by putting together a series of packages, MODFLOW packages that provide the correct set of functionality that we need to simulate our case, right? And so in Flopy, we're gonna for each package that we want to add, we're gonna create a Python object or a Flopy object that has all the information needed to write the input file for that package. So in Flopy, all packages, all MODFLOW packages have their own object associated with them. All right, and what I mean now, I said up top that these objects can be nested. Well, as an example, if I have this object, this is my MODFLOW top level object. This is a MODFLOW simulation. All right, it can have an attribute that is a package, say the discretization package. All right, and that package will be another object, right? And then when I access that particular object, I'll get all the attributes that object may or may not have. So as an example, you know, the well package has its own object in Flopy. Okay, so the process of creating a model in Flopy is basically defining or instantiating, which means bringing into existence the required objects and defining variables defining the variables needed for each object. And then finally, writing, using these objects that we've created and the variables that we've sort of filled in for each of the objects, we write the input files for MODFLOW. And this will be a method. So we are not going to physically write them. This is a function or a method, actually of the highest MODFLOW model object. It's basically write input files, and we're going to call this function, and it's going to take all the objects that are associated with our model. All right, and it's going to write input files for each one of those objects or packages. Okay. So what's really useful here is when we do this, when we create or do these steps, in a Python script or Jupyter Notebook, right? We are saving a record of everything that we're doing to create our model. All right, there's a written record of the steps we took to make our model. All right, this is incredibly transparent and reproducible now. If someone wants to recreate our model, they can go look at our script. They can see exactly what we've done. All right, so this is really important and very useful, and a really great advantage of using the scriptable interface. The other natural advantage, and we'll get to this a little later, is that all of these, because we're doing everything within Python, any kind of pre-processing or post-processing we want to do, we're going to have access to all of the rich capability of Python libraries to do whatever we want to do. And so we have a whole lot of external capability to make any kind of calculations or pre-processing computations that we want to make. So our scriptable user interface is extremely powerful. It contains all the power of all the libraries written in Python. And so, you know, all of a sudden we have access to whatever someone else has written in Python. It's very amazing. Okay, so some basic just Flopy utilities that that I think are worth me mentioning now, just as a very, you know, initial start. All right, so these are just things that will help you sort of get started, or at least conceptualize when you start with Flopy. So first of all, help/documentation. All right, there's a Flopy website that has the documentation, but and so that Flopy website is really useful. All right, you should have that up when you're working with Flopy. But you can also have use of standard Python help/documentation commands. And Flopy is pretty well documented. So use them. If you're, for example, wondering what attributes an object has, you can just type in the object name and a question mark, hit enter, and you're going to get a really good description of that object. All right. So really, really useful set of help is at your fingertips in Flopy. All right. This documentation is really specific for Flopy and how Flopy works to write MODFLOW. So I'm just going to say that in unison, you're always, whenever you're working with this, you're always going to want to have the MODFLOW manual ready when you're working with or Flopy, so that you know, okay, I'm in the well package and I'm trying to define, you know, the pump rate. What are the parameters that I need? What is MODFLOW looking for? All right, and you'll be able to look up the well package in MODFLOW manual and see exactly what that package needs. All right, so help. This is probably, you know, the number one thing you're going to want to start off with is just starting to explore the help and the documentation. All right, anytime we're going to write a command, it's worth looking at the documentation and figuring out what we're doing. So some other utility that that Python has. So we might also think then about, oh, went dark here. Pre-processing. All right, and when we're pre-processing, there's all kinds of steps that we're going to be doing, but you know, one of them may be trying to take data sets from the real world to help us construct our model domain. So spatial data is often something that we're going to be working with. All right. There's a lot of rich GIS and interfaces that are available in Flopy. So GIS, raster calculations, all kinds of really good, useful things for us that we can do available to us, both through Flopy and in general, just in Python. Any kind of calculations. So we may want to take certain data points, say precipitation data points, we might want to interpolate those. So to create a field of precipitation. These are all things that we might need to do to create input files. So interpolation, other calculation. Maybe we want to calculate the potential evapotranspiration given a temperature data set. All right. And all of that in Flopy, since we're working in Python and we're creating this model in Python, we have the full power of NumPy and SciPy at our disposal. All right, so there's just an unbelievable amount of utility in that. So this is incredibly useful. So for pre-processing, there's basically, there's no limitations on what you can do or what you can think up in order to create the data sets that you need to run the model. And the entire suite or capability of Python is at your fingertips. All right, you're not limited in any way by what the programmers of your GUI platform have decided or have been able to create for you. You have the entire suite of Python at your fingertips. For post-processing, you've got canned routines. For reading the MODFLOW binary files. All right, so you don't have to worry about reading in a binary file. Flopy has routines that can basically just automatically read that binary file. And when they do that, they're automatically these output files are read into Python arrays or NumPy. All right. Oh man, this is one of the very best features. Now there are all kinds, there's no limit to the type of calculations that we might want to make or can make. Calculations or analyses that we might make. All right, we can, let's say we are interested in the statistics of the head and what's the average head, what's the min, what's the max. These are all really easy things for us to calculate using just standard NumPy built-in functions. All right. There are canned routines for making common plots. So at the end of the day, what we want are pictures that allow us to display the results of our simulation. For really common plots, like say the head in a layer, there's a canned routine. It'll plot and contour the heads. All right, and then there's a canned routine for plotting velocity vectors of the groundwater flow field. But for more custom plots, again, our data is in a Python are in NumPy arrays. And so there's all kinds of libraries and utilities used in Python for displaying these arrays. All right, so we have access to all. Plotting utilities. All right. Okay, so for all of this post-processing, again, the data is in Python arrays, so the world is our oyster. We can do all kinds of stuff with it using the power of Python. So, you know, the disadvantages of Flopy as an interface are that it's not visual or as visual. We have to learn to use Python and write Python code. But there are so many advantages in terms of the types of calculations we can make and all the utilities for making these really complicated pre and post processing functions. And it's really up to us and our creativity now to unlock and use Flopy to create really interesting models in MODFLOW. All right, so we'll start working with actual examples of both running MODFLOW and creating MODFLOW models using Flopy. But this just gives you a bit of a background and overview into the sort of underlying thoughts and why we use Flopy. I hope it's been useful, and I'll see you guys on the next one. Cheers.